Solving two-step equations, but the first thing I do want to do is just do a couple notices. As you're going through this video, if you need to pause to write some stuff down, go for it. That's what you need to do. Pause it, write it down, hit play again, and then listen to me talking about it. So right now might be a good time to pause it, write down the problems, come back, and we'll solve them. So just a couple basic things, kind of getting our brain going, remembering some integers and all that stuff. -4 plus 4. So it's like I owe somebody $4. I get $4. I pay them back. I now have no money. I paid off my debt. 7 minus 7, again, 0. If I have $7 and I spend $7, I have no money. -15 plus 15 is also a 0. 10 minus 10 is also a 0. This is what we're going to be looking for part of our solving equations, is making zeros. If you'll notice, one of them has a minus, one of them has a plus. This is a positive number if there's no sign in front of it, and a negative, and so on. If we look at the rest of them, while this does look like a fraction, it is also division. They are interchangeable. So you can think of them as a 3/3 or just 3 divided by 3. Anything divided by itself is 1. 1/5 times 5, very similar. If we make 5 a fraction, we can make that a 5 over 1. Multiply numerators, multiply denominators. 1 times 5 is 5. 5 times 1 is 5. Kind of looks similar to those 3/3 over there. That also gives us a 1. 9 divided by 9 is 1. And if we use our pattern recognition, 1/10 times 10 is also going to be 1. In this problem, we have a combination of division and multiplication, and we're making ones. It's going to be very important that with multiplication and division, we create ones. So we're going to be creating zeros, we're going to be creating ones. So I have a bunch of steps on solving equations. These are very detailed. I do want you to write them down so that as you're going through a problem, if you forget how to do a step, you can always look back at the steps that you wrote. Again, you might want to pause this, continue it as when you have it written. So step 1 is to identify where the variable is located. It could be on either side of the equation, could have numbers in front, behind, who knows. Step number 2, is a number being added or subtracted to the variable? This is the first thing that we're going to be looking for. Is there something being added or subtracted? If there is, we're going to use an inverse operation on both sides of the equation. Now, an inverse operation you might have also heard as an opposite. Addition and subtraction are inverse operations. They're also opposite operations. So if you see that there's a number being added to the variable, you're going to subtract it from both sides. If you see something is being subtracted from the variable, you're going to add it to both sides. They go back and forth. Now that we've dealt with the addition and subtraction, you're going to do the same thing with the multiplication and division. You're going to say, okay, is there now something being multiplied or divided to the variable? And if so, you're going to use those inverse operations again, but this time it's if it's multiplied, divide, and if it's divide, you multiply. So the addition and subtraction is where you're going to end up with those zeros. The multiply and divide is where you're going to end up with those ones, like we talked at the very beginning with the notices. So let's go through a couple examples. You may be at different steps of understanding this. That is awesome. Some of us might be getting pretty good. Some of us might be needing a little bit of help. Wherever you are in this process of understanding how to solve an equation, it is very important that you know how to. So that's why we're going to practice again. Now, when solving an equation, some of us may have seen drawing a line down the equal sign. It makes it easy to see left side, right side. Might have heard of it as railroad tracks, might have heard it as a fence, just a line, whatever it happens to be. So let's go over those steps. First thing, find the variable. It's right there. Okay, do I have something adding or subtracting the variable? Yes, I do. I have a +1. So if I want to undo a +1, I'm going to -1. So I'm going to subtract 1 from both sides. And again, that line might help you visually see left side has a -1 and the right side has a -1. Now this -1 minus 1 is our 0. So we found our first 0, which is good. Now we're going to do some simplifying. So if that's a 0, the only thing I have left on the left-hand side is a 2x. On the right-hand side, I have 15 minus 1, which is 14. So my next step, do I have something multiplying or dividing the variable? I have something multiplying. If you have a number with a variable right next to it and there's no sign in between, no nothing, that means it's being multiplied. So the inverse of multiplication is division. Now with division, we are not going to use the little dot with the little line with the 2 dots on top. We are going to use a fraction bar. When you get into high school, this is what your teachers are going to be looking for. Do you know how to appropriately draw the fraction bar? Do you know how to show all of your work? So we're going to divide both sides by 2. This right here, this 2 divided by 2 is our 1. So we've just found our 1 that we're looking for. And 1x is the same as just x. So we don't have to write our 1. We're just going to write our x. And 14 divided by 2 is 7. Now, I did kind of mention something. I'm just going to reiterate this again. This is showing your work. If you just went straight from the problem to the answer, I'm going to say that's great. You know how to figure out those numbers in your head. That's a great tool, but that's not what we're practicing right now. What we are practicing is showing our work so that when we get into like an Algebra 2 class and your problems have decimals and fractions and positives and negatives and your equation takes 6, 7, 8 steps, you know how to show your work and keep track of what you have and have not done along the way. So we are not just doing mental math of saying what number times 2 plus 1 is 15 and going, yeah, the answer is 7. Great. I'm glad you have that skill. But we are practicing showing our work. So make sure that right now you're also writing down and showing your work. Okay, for next problem, problem number 2. 18 equals 5x minus 2. Okay, so my variable's on the right-hand side. It's on over there. With my variable, there is this minus 2, minus 2. So I'm going to say, okay, what's the opposite of minus? That is plus. I am showing my work. I'm showing my plus 2 on both sides. My negative 2 plus 2 is gone. It's a 0, which leaves me with just my 5x. And 18 plus 2 is 20. So now I have my variable. It is being multiplied by 5, again, because if a number and a variable are next to each other with nothing in between, that means they're being multiplied. So to undo that, I'm going to divide. That is my inverse operation. 5 divided by 5 is 1. And then we have 20 divided by 5, which is 4. So we've now solved it. 4 equals x. It's okay that our variable's on the right-hand side. Our variable can be on either side. It's absolutely fine. So 4 equals x, and you could even say that as x equals 4. Same thing. Okay, let's get into some more positives and negatives in our problems. So negative 4 minus 7 equals 33. Again, here's my variable. Behind it, I have a minus 7. So to undo a minus 7, I'm going to add 7 to both sides. So there's my 0. Negative 7 plus 7 is 0, which leaves me with a negative 4x on the left-hand side. 33 plus 7 is 40. I'm going to divide both sides by negative 4. And I want to talk about this really quickly. While there's a minus sign in front of that 4, that means that it's a negative 4. And that negative 4 is right next to that x. There's no sign, no nothing in between. So this still means multiplication. That still means negative 4 is being multiplied by x. So if I want to undo multiplication, I've got to divide. So negative 4 divided by negative 4. Not only is 4 divided by 4 a 1, but a negative divided by a negative is a positive. So I don't have to worry about my negatives. They're gone. On the right-hand side, 40 divided by negative 4 is going to be a negative 10. 40 divided by 4 is 10, and a positive divided by a negative is a negative. Okay, let's try another one. So x over 2, remember this is our fraction bar, but it's just division, plus 11 equals 10. I'm going to say my variable's right here. With it is a plus 11. To undo a plus 11, I'm going to subtract 11 from both sides. So that's gone. It's a 0. I have x over 2 equals, and 10 minus 11 is a negative 1. So we're getting into that integer world. If I have $10 and I want to buy something that's 11, I better be able to borrow a dollar from my friend. So this one is a division bar. Fractions are division. So if it's division, I'm going to multiply both sides by 2. We are not going to put a times 2 on both sides because all of a sudden it looks like I have an x with another x. That is not good math. That is sloppy math. The way that we show multiplication is we do parentheses on both sides. Those purple parentheses with the 2's mean that 2 is being multiplied on both sides. Now, if I were just to extend that fraction bar, I can see that this is 2 divided by 2, which is my 1. They still reduce. So I have my x by itself right now. My x is isolated, which is a good word to know. That means that my variable is by itself. I have isolated x. And negative 1 times 2 is negative 2. So I've solved my equation. Okay, problem number 5. We have negative 3 equals negative 9 plus x over 4. So here's my variable. We have a plus sign in front of it, but we also have a negative 9. Now, since our variable is in the back, this plus really belongs to the x. That means that our x is positive. Our 9 that's sitting up here is a negative, and a negative and a subtraction are interchangeable, which means you can say them both ways. That negative 9 really means that 9 is like being subtracted. So those are the same words, the same signs. So that means that if I want to get rid of a negative 9, I need to add 9 to both sides. Negative 9 plus 9 is gone. I have my x over 4. I don't have to write my plus sign because that's now just become a positive. And negative 3 plus 9 is 6. I owe someone $3. I got $9. I pay him back. I got 6 left. So this now is x is being divided by 4. I'm going to multiply both sides by 4. Use those parentheses on both sides. 4 cancels. And we have 4 times 6, which is 24. Okay, we have 2 more problems left because they're special cases of something that you might see. And you will see it on today's assignment. So this is our very first special case. So in all of our other problems, the first thing that we undid was addition and subtraction. However, on this problem, there's a different thing happening because if we look at this fraction, this 2 is dividing both x and negative 3. So that dividing by 2 is affecting the subtracting of 3 also. So we have this one really big fraction. So the first thing we actually have to do on this one is get rid of that really big fraction. So I want you to notice the difference. If you look at like number 5, the fraction is just with the x. That is its own little fraction. In number 6, the whole problem is a fraction. So that's why it's different. Look for the ones that the whole problem is a fraction. So if I want to make it so that the entire problem is not a fraction, I have to get rid of the fraction part first. I have to get rid of the divided by 2, so I'm actually going to multiply both sides by 2 first, which will allow me to say that our 2 divided by 2 is a 1, and we don't have to worry about it anymore. Now 5 times 2 is 10. So since this problem was one huge fraction, I had to get rid of the fraction first. Then I can finish my problem saying if I have a minus 3, I'm going to add 3 to both sides, and x equals 13. So this is one of those special cases, so look for that. Now here's the other special case. Negative 2, and then in parentheses, 8 plus x equals 12. So while this negative 2 is being multiplied, it's actually the first thing that we have to deal with because it's being multiplied by this big addition problem. So it's affecting the rest of the problem. So if you have a problem like this, there are other ways to solve this. I'm just showing you one of them. So for those of you who know something called distributing, go for it if you know how to do that. If you're not sure, we'll talk about that later. Don't you worry. So one of the ways that we can deal with this is if I want to get rid of the multiplication of -2, I can first divide both sides by -2. That will help me reduce my -2's. Anything divided by itself is 1. So I am now left with 8 plus x equals -6. And then I can say, okay, my x has an 8 in front of it. So this 8 is a positive 8 because there's no sign in front of it. So it's like a plus. So I'm going to subtract 8 from both sides. Cancels, and x equals 6 negatives and 8 negatives make 14 negatives. Okay, so while you're doing your practice, if you're not sure how to solve it, ask for help. Make sure you are showing your work. Your work is what you are practicing, not mental math, not guessing what the answer is and checking. It's showing your work. So make sure you show your work, and good luck to everybody and have a great day.